presenter for the day, and Scott, you are now in control.
Okay, and here's my screen. I'm hoping that everyone can see this, and this is a nearly finished version of the model that we're going to be working on today. I'm going to introduce things by first reviewing the folks who are here to help answer questions. I'm the presenter, Karen's the organizer. Elizabeth, Daniel, and Andres are all online, prepared to answer questions that you ask through the chat panel. And let me begin by just saying a couple of things about modeling. You know, the Common Core standards mention modeling in a number of respects. So it's obviously considered important, at least for the Common Core. And I'd like to talk a little bit about why modeling can be so important. One is because the sort of challenges, real-world challenges that modeling involves, tend to be very motivating for students. Students like doing projects. And the idea of modeling, of mathematical modeling, is we take on a project that requires some significant mathematics, hopefully that students don't already know. So they get to see the value of mathematics in real contexts. In fact, the actual use of mathematics in the rest of the world, outside of school, isn't organized according to particular topics in a textbook, but it's organized according to models that people need to create and figuring out what mathematics will allow them to do that. So through modeling, students also have an opportunity to analyze and describe what math they're going to need to learn. And they value our questions, hints, and the other help that we give them, because those things are helping them to create the model that they're trying to make. And at the end, they take a lot of pride in the mathematics that they've created themselves. Let me take one moment here to show you a sketch created by actually the original of this sketch is one of the samples that's in Sketchpad 5. But what I'm showing you is a sketch created by a young man by the name of Jiali Ma, who is going into 10th grade this coming year. He saw this model and decided he was going to explain how it was built. So he investigated it. So here's the actual result of this particular sketch. We have a parabolic reflector, a light source, and when light is emitted from the source, let me emit it again here, we see rays going in a number of different directions. Each ray bounces off the parabolic reflector, and they all go the same direction. This is the principle of a headlight. This is a sample that comes with Sketchpad 5. It came with Sketchpad 4 as well. And young Jiali decided that he was going to show how we built it. So he took the information tool and he looked at how the locus, this parabolic reflector was constructed as a locus. He looked at hidden objects. He looked at the circle interior and figured, well, this comes from circle 1, which is centered at point number 3, and used the information tool to analyze what was going on. And he created a 10-page sketch in which he said, well, step 1, we start with a line AB. And he's on his way through these first few steps to describing how we created the parabola. So this is not his own model, but this is the excitement that the model that he saw built in him and inspired him to figure out how we had done it and to make it his own. So that motivation to make something your own is much stronger in an interesting model like this than it is in just an assignment where you follow the steps and do the construction that's listed in the steps. So I wanted to show that first. And let's continue now with the agenda and with building our own model. Anyone who has comments or questions about the process that Gialli went through and use of the information tool and that kind of thing, you can ask in the chat. And if any of the other organizers who are answering these questions wants to break in at any time, please do so and stop me and ask with questions during the rest of the presentation. All right, I'm going to say one more thing about modeling, because modeling is different from applications. With applications, you know, the end of a particular set of questions from a lesson in the textbook often contains applications. There, with applications, the mathematics is already decided, because it's the mathematics that was in that lesson in the textbook. And what these questions are doing is trying to illustrate where in the real world this particular mathematics might be used. And that's the opposite of the approach of modeling. The approach of modeling is to say, here's a real world problem. What math do we need to do it? And at the end, I'd like to come back after we've created our model and think a bit about the mathematics that this model required us to use. So here's going to be our agenda as we go to model the carousel. We're going to create a top view of the carousel and some attachment points on which to put our horses. Then we'll use that top view to create a side view, and we'll stick one horse on. We use Sketchpad's iteration feature to create the remaining horses, and we'll animate the result. So we'll get the horses going around the carousel. Once we have that going, we have most of what you saw on the title page, but there are a couple of fine points, one of which is to insert depth into that side view so that the front horses pass in front of the back ones, and another is to make those horses go up and down. You might have noticed the horses on the title page that I showed you were not going up and down. We'll make ours go up and down like real carousel horses. All right. So I'm going to skip over the conclusion and resources. We'll come back to them at the end, and we'll begin with the top view. An empty sketch. So we actually have to create the top view from scratch. Let's go ahead and do that. The top view of a carousel is basically a circle. Because I want to keep things adjustable as I go along, I'm going to begin with a segment and use this segment as the radius for a circle that I will center right here. So with the point and the segment selected, I'll construct a circle. That's a little large for my screen. So here's where the fact that I have a segment to control the circle is good, because it allows me to scale my top view and to make the top view as large or as small as I need for the work that I'm going to do. And I can later scale it up. I can scale it down as I'm working and so forth. All right. Now, we want to put a horse that goes around this carousel. So let's use a point on the circle. This will be our horse. And with the Edit menu, I'll create an action button, an animation action button, to move counterclockwise around the circle at medium speed. This will be our Animate the Horses button. And if I press that button, presto, our horse is animating around the screen. Well, around the carousel. We have to use a lot of imagination to see where this is going to lead us, but eventually that will be the animating horse. Now, we also have to decide how many horses we're going to want around this carousel And we'll need to know that before we can put the next horse's position onto the circle. So I'll begin that from the number menu, choosing a new parameter, which I'll call n. And let's begin, let's say, with a dozen horses. That's an arbitrary number. We're going to be able to increase it or decrease it later on. So the second horse now needs to be an appropriate distance away from the first horse to allow us to fit 12 horses. So already we have a little bit of mathematics that students are going to have to confront. How can we divide this circle up so that 12 horses fit around it? Well, we'll need to calculate 360 degrees divided by the number of horses. And I'm going to click over here on the parameter n rather than typing 12 because I may want to change n later. So I'm going to make it 360 over n rather than a fixed value of 360 over 12. So that tells us how far apart is the central angle our horses will need to be. All right. So let me pause my animation for a moment. And let's rotate the first horse by 30 degrees, and we should get the position of the next horse around the circle. So I'll select the first horse, horse number 1, rotate by our 30 degrees. Whoops, did you see what just happened? Did you see the animation around this center point? That told us that Sketchpad was choosing this center point A to be the center of the rotation. Sketchpad was just making a guess because I hadn't told it. I could have told it by marking a center ahead of time, or I can tell it now by saying, oh, I don't want to rotate about that. I want to rotate about this point. Watch what happens when I click. Click. Now that point's been animated as the center point. So it would rotate about this point. In fact, Sketchpad did guess right the first time, so I'm going to switch the center point back to here. And now the angle is indicated as 90 degrees. That would be around to here. But I don't want 90 degrees. I want this value. Notice again, instead of typing 30 degrees in here, which would be a fixed value, I'm clicking in the sketch to use the 360 over n. So if I ever change n, my horses are rotated appropriately. All right, so now I've got the second horse. And those horses can go on moving around the circle. I'm not going to do more than that right now because I'm going to use iteration later to have Sketchpad take my first horse and the point at which I want the second horse to appear, and Sketchpad will be able to take that one horse and say, okay, you want the second one here? I'll do it. And now I know where the third one and the fourth one and the fifth one go. So that's the way we'll use iteration in a few minutes. All right. So I guess we're done with the top view. Let me stop and just make sure there are no questions before I go on to turning this top view into a side view.
There have not been any questions. I think everyone's just really watching and paying attention. So again, just a reminder, if you have any questions, you can type them in the chat panel, and if we can't answer them ourselves, we are going to pass them on to Scott.
Okay, doke. I'm now going to use a technique. I mean, I had a different page set up here for the side view, but I often, when I'm building something in stages, when I'm building something complex, I often decide, well, you know, if I go to the side view page, I don't have anything there yet either. I could copy everything I have here on the top view and then paste it into the side view and keep going from there. But what I often like to do instead is to go to Document Options and forget this side view page. I like to duplicate what I've already done. Duplicate the top view page and continue renaming this as the side view 1, let's say, and each time when I go onto a different stage of my construction, I'll do it in a new page. And that way, if I really mess up, I can always go back to that previous step in the construction and continue from there. Now, I can also do that with undo and redo, but sometimes I like to have a record that I can just jump back and refer to of how I did different steps. So I'm going to do that here, and the result will be for you that you'll have snapshots of where the construction was at different stages as we went along. All right, I'm going to put the side view below this top view, so I'm going to move these things down so that we still have ready access to them. And with the Alt key or the Option key on Macintosh, I'm going to move this circle up towards the top so that we have some room down here to actually create our side view. And let me put this control up there. So let's see, I want the side view centered below the center of the circle. And the side view is going to go out by this much from that center. So thinking about how to create that, I think I want to create a ray that goes from here directly down. And I'm holding the Shift key down to make sure it stays vertical. But then I realize, oh, if I actually drag either of these points, it's not going to stay vertical and my construction is going to be messed up. So I want this to stay vertical. I'll do that by going to the center point and transforming that by a translation. 100 pixels at 90 degrees would be 90 degrees up. I'll make this 270 degrees, so we end up with the point going to be there. Yours will normally come up as centimeters instead of pixels. It doesn't matter. You can use whichever unit you have things set up to work in. I like to use pixels because the sketch comes out looking exactly the same in the window, whether you open it on Macintosh or Windows. So that'll be my translation. And to get the ray going through there, instead of through an arbitrary point, I'm going to select both of these points and merge them. So now I have a ray that is vertical no matter what. And let's see. So for the side view, I'm going to want a floor for my horses and a ceiling for my horses. So I'll make those 2 points my floor and ceiling. So let's call this one ceiling and call this one floor. So now we've got those labeled. And to actually make the ceiling and floor, I'm going to want to go this far so that it's exactly matching the width of the circle. So I can do that with the translation. I'll translate both of these points. And rather than by some fixed distance, I'm going to use the distance from this point to that point and also the angle. So that's actually a marked vector in Sketchpad's transformation lexicon. And I can indicate that marked vector by clicking first on the beginning point and then on the ending point of the vector. So my beginning point here, my ending point there, if I do the same translation for points ceiling and floor, you see what I get. So these are the ends of the ceiling and the floor. Now, I need to know where the equivalent point is on the other side, which I could do with a vector translation from here to here, or being lazy, I always strive for the easiest transformation I can do, and in this case, double-clicking the ray to mark it as a mirror and reflecting is actually a little bit easier. So that's just my laziness at work here. I can now finish off the ceiling and the floor. And now I'm ready to try to figure out where to put on the floor my first horse. If there are any questions, this is a great time to stop me. If not, I'll just keep going.
Not seeing any questions.
Okie doke. So, where am I going to put this first horse? Well, I'm going to have to track down from here to where this hits the floor to see where on the floor the horse ought to go. So let me construct through here a parallel to my vertical ray. So there's a parallel. And this right here should be the starting point for that horse. Let's see if I got this right. Let me animate that horse. And we can see the horse going from side to side around the carousel. It goes now around the back of the carousel and comes back to the left-hand side and makes the turn at the left and comes back around the front. So that's looking pretty good. I'm not going to bother creating the second horse because Sketchpad's iteration is going to do that. I only have to place my first horse. So let's see, I could place the first horse all the way over to this point, but then the horses would be right nose against tail, and we need to leave some space for the kids to walk to get through between the horses. So I don't want the horse to extend, first horse to extend all the way to the second horse. So let's say we use maybe, what, 75%, 80% of that space for the first horse and leave the rest as a passageway. I like everything to be adjustable. Number of horses, the size of the carousel. So let's make our percentage adjustable as well. Here's an easy way to make an adjustable percentage. Take the segment tool, holding the shift key down, I just construct another little segment to use as an adjustment. And then I'm going to put a point on that segment and measure the value of that point on its segment. Notice the result. Point G goes from 0 to 1. So I can consider this to be 80%, let's say. And I can use this ratio as a ratio of this full distance to make the front and back of my first horse. Now, let me think for a moment about how I would use this ratio to figure out where the front of this first horse needs to go on the top view. This angle, the central angle from here to here, is 30 degrees. So if I were to multiply that 30 degrees by 0.8, that would tell me how much to rotate by to go to the other end of this first horse. So that's some interesting mathematics that kids would have to deal with in creating such a model as well. Let's go ahead and do that. Take the 30 degrees times the 0.8. That will be 24 degrees. We're using this point to rotate it by the 24 degrees. So transform, rotate. Now, Sketchpad, did you see the animation down here? You might or might not have seen it. But Sketchpad, because this is a new page, doesn't remember the center point that we used in the previous page because this isn't the previous page, it's a new one. So I actually have to mark the center point here as well as clicking on the 24 degrees to do my rotation by. Now I see the point in the correct spot. Go ahead and rotate. The rest is easy. Rotated that point, construct a parallel like we did before, and now we know where we want that first horse to appear, right within this rectangle. All right, so I'm ready to do that. Let me jump over to the window in which I have my photographs. Oh, there's a nice Flickr photograph of a carousel. I don't know if ours will look quite this nice. We'll do our best. And here is a public domain Creative Commons picture of a horse that we're actually going to use. So I will select this horse. I could have, by the way, dragged it from my web browser into Sketchpad. I already have it in Sketchpad, so I'm going to copy it from this page and go back to my carousel and paste it here. Now, if I paste with nothing selected, I just get the horse, not attached anywhere. That's not what I want. So I'll choose undo. By the way, I just used the keyboard command for paste. I could have gone to the edit menu and chosen paste. So I'll choose undo, and instead let me try pasting it to a point. So I can paste the picture to a point, and now the picture is attached to that point, and wherever the point goes, the horse goes. But that's not what I want either. So undo again, keyboard command twice to undo, 3 times to get rid of the point. If I had 2 selected points, actually let's do that right down here. If I had this point and this point selected, and I paste the picture between those 2 points, then I have something that looks much more like what I want to have, except for a problem that occurs when we animate and the horse comes to the end of the carousel, makes its turn, and whoops, it's flipped direction, which I don't want. Now it's going clockwise around the circle where I created it to go counterclockwise. So that's no good. So I'm going to undo one more time, get my horse back to where I wanted it, and instead of pasting to 2 points, I will paste to 3 points. And the 3 points are going to be the sort of the origin. Think of this one as the origin. Think of the next point as being the x-axis and the third point as being the y-axis. In other words, origin, horizontal, and vertical. Paste the picture there. It looks like it did before, except that because we've said that the picture needs to go horizontally from here to there, when it goes around to the back side, the horse does the right thing. All right. So now we've got our first horse, and we're ready to animate, and we have our first version of the model. Good time for questions while I go to a new page and duplicate what we've got so far so that we have all the various stages captured.
I'm not seeing any questions, so if anyone has any questions, now would be a great time to send them in. But I think everyone's just kind of watching and paying attention. It's a lot to absorb, and it's exciting.
Okay.
But there's no questions that I see, Scott. Sorry.
Well, let's go ahead
and
let's go ahead and check this out. Let's see if by building this one horse carefully, if we can't have Sketchpad duplicate this and give us a whole carousel's worth of horses. So here goes. The controlling point, the very first one that I created to identify where that horse should go. Oh, by the way, I should have mentioned something earlier. notice how the horse really does seem to turn the corner as it reaches the edge of the carousel. And that's because we have the top view in which the horse has a certain length. We have that converted to the side view where the width of the horse, where the horse really is turning, and we get the view correct because of the connection we've made between the top view and the side view. So this is our controlling point. The next horse needs to go here. So we want Sketchpad to do at this point what we've done already at that point. We also want to have Sketchpad do it the correct number of times. So ignore the correct number of times for the moment. If I were to choose this point and tell Sketchpad iterate from this point to this point, then Sketchpad will automatically assume, well, three horses, that sounds good, because I haven't told it how many. And we can actually use the plus key on the keyboard to increase the number of horses, and you see more horses going behind there. But I don't really want to do that. I just undid, because what I really want to do is make the correct number of horses for n. I've made 1. That means I need 11 more. So let me calculate n minus 1. And now I can say, take the original point, the independent point that is the seed for our iteration, and this many times I hold down the Shift key to transform the command which used to be iterate is now iterate to depth because I have the Shift key down. When I click that and tell Sketchpad iterate that first horse to this location for the second horse, I now get exactly the number of horses that I need. Now you notice that the iteration includes not only my horses, but everything else I constructed. Well, I guess that's no surprise because I didn't tell Sketchpad which things I wanted. I just said, redo the same construction over and over again. But it's really only the horses that I want. So I can either hide or even delete the extra things that I don't need. I just have to be a little careful to make sure I don't delete something on which the horses depend. So I'm going to start with all these vertical lines, the parallels that I made, and press the delete key and get rid of them. Okay, I still have my horses. That's not bad. And I've got some intersection points here that I use to place my horses. So I'll select them and press delete. And the horses are still there. So far, so good. And I've got some more such points, and I'll delete them. And now I pretty much have exactly what I want, except that these lines are also interfering with my view of the carousel. So I'm going to not delete these. These I need to hide, because if I were to delete them, I'd be very sorry because my horses would go away. All right, so let's animate again and see if we have something near what we're looking for. So that's not bad. And I'm even ready, I think, to increase the scale and see a bit more of what's going on here. I did, by the way, notice that we have a few extra points going around the circle as well. That's the iterated images of our original point and the point that shows how far to make each horse go. So I'll get rid of those as well. And let's just check and see how our adjustability works here. Let's see, we have the ability to make the carousel wider and narrower. We have the ability to raise and lower the ceiling or the floor. And we have the ability to decide whether the horses are sort of short with lots of room in between them, or whether they're very wide, extending almost from one to the next. Okay. Oh, can we make more or less horses? Well, let's try 8 horses. There we have our 8 horses. Let's try 3 horses. Oh, goodness, those are really long horses. Let's try 20 horses. Lots and lots. Okay, so we have pretty complete adjustability here in our carousel. And we're close to what we had on the very first page of this sketch. These guys are perhaps going a little fast. We get back to, let's say, 10 horses, so we can continue our work and add a couple of nice features to this model.
Unmuted.
When I did this the other day, we have 2 things that we'd like to add to this. Let me preface it by saying that. The 2 things we'd like to add are, 1, we'd like the horses to go up and down as they go around. We would also like to correct a problem that we have here with the iteration, which is, if you look carefully, and I'm going to slow this down because I know that you don't have the same frame rate that I do because of the internet slowness. You get to see this much more slow. You get to see this much more jerkily than I do. So I'm slowing things down, and you notice, so this horse is passing in front of that one. This horse is also in front of that one. But there's going to be a problem because the very first horse that I create is sometimes the horse that should be in back is going to come out in front. Oh, look, this is one of the back horses right here, and it's passing in front of the others. And the reason is which horse is passing in front of which others is in the order of the iteration and not whether they're in back or in front. So the first horse of the iteration is sometimes in front, sometimes in back, and they don't always pass where they should. So I can fix that. And the way I would fix it is to say, well, let me make 2 separate iterations. Let me make an iteration that only shows the horses when they're in the front. And then let me make another iteration that only shows the horses when they're in the back. And by making both of those iterations and then putting the correct one in front of the other, the horses will always pass where they're supposed to, with the front horses in front and the back horses in back. That's a bit complicated, but I can summarize briefly how to do it later. What I'd really like to do right now, though, is to add some jumps to these horses, because it's really a shame to see these horses going along and not making any jumps as they go. That would be kind of a boring ride for my grandchildren, for sure. So that's what we'll do next. And I'll summarize the other and give you instructions in the files that you download for how to do the front and back problem. All right. So, document options. Let's save where we are right now. Add a duplicate of that page. So this is side view number 3, or let me actually name this a little bit better. This is the ones that go up and down. So we use this page to add the up and down motion. Okay. So now for up and down motion, what am I going to have to do? Let's see. I can tell from the point here, let's see, I'm not entirely sure, but yes. Okay, here's the point to which our horse is attached. Let me bring it around to the front so we can see it both in the top view and the side view. Okay, so our horse is attached right here, here, and there. And since this was actually the original, it ends up being behind the others because the others were created later. So this is actually the original horse right here. You can see because it's only one horse when I click on it to select it. If I click on any of the others, I get the whole iterated image of 7 more horses, or 9 more horses. So this horse is the one that we need to make go up and down because he's the one who controls all the others. And these 3 points are the points at which it's been constructed. So I need these points to be going up and down as the horse goes around. All right, let's see how we can do that. Let me create one more segment which is going to determine how much the horse goes up or down. So I use the length of that segment to determine the amount of up or down motion for the horse. This is obviously going to be much too much. The horse is going to be jumping like crazy above the ceiling practically with this. But I'm starting with this just so I have a little more room to work with. And somehow I have to get a point on here that's going to go up and down. And one way of doing that, I suppose, would be to add an animation here which will move up and down. And if I were to do that, I'd have my horses moving up and down. There are 2 problems with that approach. One is that all the horses would move up and down at the same rate since they're all tied into the same thing. And you know that no actual carousel has all the horses jumping in unison. So I'd really like the amount of my jump to be based on where we are around the circle. The other thing is that I couldn't actually build such a carousel because there has to be some sort of mechanical connection between the around motion and the up and down motion. And I don't have any such connection here. So although this would be an interesting effect, this is not the way I'm actually going to do it. So let me get rid of this point, but I'm going to keep my segment because the segment will be useful. And instead, I'll say, let's find the angle between this point, the center point, and my horse. So if I measure that angle, that's an angle that once I go past the vertical here, it's going to start at 0 right here. So you see this angle at 0 degrees, and as it goes around, it's going to increase until it comes around to negative 30, okay, it comes around to negative values on the other side. So it's going to go 0 to 180, and then from negative 180 back to 0. If I were to calculate the sine of this angle, then I'd have a value that will go from 0 to 1 as we go around the circle, or from negative 1 to 1 rather. So let me do that. And I'm hurrying a bit through this because I don't want to run out of time here. I want to be sure that we finish this construction. So the sine of this angle is going to give us a value that will go from negative 1 to 1. And if I plot that value on the segment, I'll find as this point goes around the circle, my value going up to 1, and I've run out of room for dragging, but it will start back down. As we go beyond 90 degrees, it starts back down. It hits negative 180, and we can't plot it anymore because it's negative. Okay, so that was a mistake. I like making mistakes because it gives me the opportunity to fix them. So to fix this, what I'm going to do is I'm going to say, well, a segment only goes from 0 to 1. That's how we define values on a segment. So let's forget that segment. And instead of the segment, let's use a full line. Because the value on a line, when we plot this point on the line, the value on a line, this is also 0 and 1, but when we go beyond 1 to get negative values, we can go the other side of the endpoint, because it's not an endpoint, it's just a through point of the line. So when you plot a value on a line or a segment, the defining points represent 0 and 1. So here we have a value close to negative 1, negative 0.97. Okay, so that's going to be the amount of our jump. So the jump is going to go from, wait a minute, let me make sure I've got the right points. Okay, the horse is attached here, here, and here. So I'm going to translate those points by this vector from the 0 point to the current location of the plotted point. Let me make sure that this really does what it's supposed to do. Whoops, I got an extra point here. I'll get rid of that. So this should bring those points back up to 0 and then above. So here below and above. So those points are doing what we want them to do. And I'm going to attach my horse then, not to the original 3 points, but to these translated points. So let me delete, whoops, too many things selected there. I deleted too many things. I want to delete my first horse. Press the delete key, get rid of the first horse, and attach it instead to these translated points. Paste the picture, redo the iteration. Remember the iteration, I select point H and the depth, hold the shift key down. Point H goes to that point right there. Iterate. I've got some things I don't need, including some points, a table I don't need. I'd already hidden the perpendiculars, so at least they didn't clutter us. And I've got some extra points here that are kind of interfering with my nice view. I'll get rid of them and get rid of these guys. And let's see if these horses are actually jumping. They are indeed jumping, but they're only jumping once per trip around the carousel. Well, that's not good, but that's because the sine of the angle only cycles between -1 and 1 once per time around. So let's think about how we could fix that. What if we wanted this to cycle twice? We'd want this to go not from -180 to 180, but twice that far for each time around the circle. So if I were to multiply the angle here by 2, I should get 2 jumps per time around. Let's see if that works. 2 times the sine. Okay. So is this 2 jumps per circuit? It is indeed. Okay, let's do better. Let's tell Sketchpad to use a value, a new parameter. Let's call it J for how many jumps per time around. And let's make it 6 jumps for each time around the carousel. Click OK. And now I have the horses jumping 6 times each time they go around. And they're jumping awfully high. So let me adjust the separation of the points that determine this line, because that's how much the jumps are. So now I've got some nice jumps, and we're very, very close to having a really workable, carousel. I'm probably going to want to do a couple more things with this carousel. Let's just think about what they're going to be. My ceiling and floor are actually too low and too high. So I'm going to want to also transform the ceiling and floor up and down a little bit so the horses don't keep bumping their feet through the floor and their heads through the ceiling. I know how much to translate those by because it's going to be exactly the distance by which the jumps take place. So I can move those up and down. I'm going to want to put a cover over the ceiling here to make it look like a real carousel. For that, I might need to show the ray again that goes from point A. I can do that easily enough by saying point A is an independent object. Its children include this ray, so I show the ray, and that lets me put a point here and use that together with a point here and a point here to make my roof, and so forth. So there are lots of enhancements left to be done, but we have the basics that we need here. We have a completely adjustable carousel. Make it bigger or smaller, and we're done.
All right.
Let me answer questions. I also want to make a couple of points at the end about some of the interesting math that we've looked at in this carousel. So let's see if we have questions first.
There are no questions at this point.
Okay.
So if anyone has a question, go ahead and type it in the chat panel, and we'll make sure Scott gets it. But Scott, why don't you go through your summing up, because we've got about 5 minutes left technically. So.
Okay, so I just want to observe that we've done some really interesting math here. We've created an object with n-fold rotational symmetry, our carousel. We've converted the circular motion in the top view into side-to-side motion in the side view. We've used an adjustable ratio to size our horses properly. We've used a trig function to make them jump. And we've transformed the trig function to make them jump the way we wanted them to jump. And once you use the detailed instructions about how to make the front horses separate from the back horses, we'll have used some conditional logic to make the front horses disappear when they go around back, to make the back horses disappear when they come around front. So it really will look like the original carousel that I showed you at the beginning, where the front ones stay in front, the back ones stay behind, and you'll have this with the horses jumping. Yay!
Okay, Scott, we've got a couple questions. One is from Callie, I hope I'm saying that right, and she just wants to know, what questions might you be asking the students about this? What could you pose to the kids about this?
Well, what I would be hoping to do is to have small groups of students working on creating a model like this, sharing their work with each other, and in the process, I'd be asking lots of questions, and I would be perhaps, this might be, for instance, a project that takes several lab sessions, and in between those sessions, we'd be looking at perhaps transformations of the sine function and seeing how the period increases if we double the angle before we evaluate the sine. And using that fact and exploring some additional transformations of the sine function, because we have to be able to modify both the amplitude and the period to get the horses to jump right. So I'd be using regular class periods to do those kinds of things. So this is actually a significantly longer-term project because of the interesting mathematics that we get into in the process. I'm not sure if that exactly answers the question, but
I think it was good. And there's one more just logistical one. It's come up twice, so I might as well ask it. They wanted to know if you can reverse the direction of the horses. And I know the answer is yes, but could you just real quick show how you would do that?
Sure. So let's go to our last page. Let's look at the properties of the button that actually animates the horses. So I'll select that button, choose properties, and the animate properties allow me to go either counterclockwise or clockwise. So now the horses are going the opposite direction because point H is going clockwise around the circle instead of counterclockwise.
They just look like confused horses going backwards.
Well, they are confused.
Okay, I don't see any more questions, so if you want, I know you had some final resources and stuff you wanted to show, if you wanted to get there.
Well, we're going to provide for you a zip file of all the webinar materials, and the recording will be available. Karen will send out an email with the appropriate URLs for that.
Or you could just go on our website, keypress.com/webinars, and all the archives are there. Right,
and that includes all the webinars that we've done over the last year and several months now.
Exactly.
I want to mention Sketchpad lesson links just because it has so many valuable Sketchpad activities in it. The zip file will also include Xiaoli Ma's reconstruction of the headlights model, just as a nice example of what one student did when confronted with a challenging construction and trying to deconstruct it and make it his own by figuring out how it was all done and then telling his classmates how they could do it from scratch.
Okay.
So that's kind of a nice added feature here.
Okay, and all of that will hopefully be up by the end of the day tomorrow. I got my fingers crossed on that one. And just a couple things to point out. There is a beginner's Sketchpad webinar next month. It is August 16th and 17th. So again, that's for actual beginners. I know we had a lot of beginners on here, so this one might have been a little bit overwhelming. But there is an actual beginner one next month as well. So stay tuned for that. And another place to go to get some great resources, participate in a community of Sketchpad users, is to go to our Sketch Exchange. And that is sketchexchange.keypress.com. And that's a free site where other people share sketches like Scott's here, and you can ask questions of others. So just something to think about. And if there's no other questions, which I am not seeing, we are going to end this webinar. We really appreciate all of you coming back after all the technical problems we had yesterday. We appreciate your support. Thank you so much, Scott, for sharing these ideas. And thanks, Elizabeth
Karen?
and Daniel. Yes, Scott?
Karen, let me mention one other webinar that we're going to have soon, which is at the very end of August, August 30 and 31. I'll be doing a webinar on geometric functions. And
that's right.
This is going to be a more detailed explanation of a new approach for most of us to introducing the concepts of function geometrically, for which the August issue of Mathematics Teaching in the Middle School has an article on that I've written on this I think very valuable approach that I think is appropriate not only for middle school but also for high school and even up to Algebra 2 and pre-calculus for clarifying some of the issues that kids have with the concept of function. So that's my quick self-promotion.
Right. Quick plug. No problem plugging. I think it's great. So that means we have two webinars coming in August, and that's because August has that extra week stuck in there. So so August 16th and 17th, and also August 23rd and 24th. Two Sketchpad webinars coming up, so you can get those on our website. So again, we're gonna close the webinar out. Thanks everyone who was on, Daniel and Elizabeth for helping us, and Scott for doing a great presentation. Thanks for everyone coming back, and we will end this webinar, and I hope you all have a lovely evening. Thank you.